What are both values of x which satisfy root x plus root x is equal to x? Well, some of you probably could solve that just by inspection, but let's just do the algebra. It's probably better that way. So this would be 2 root x is equal to x, and if you square both sides, it would become 4x on that side, and that would be x squared. Put everything on one side, x squared minus 4x, and then factor out the x to make it a little bit more obvious. And there you go. So therefore x would be either 0 or 4. Of the 4 integers that satisfy 50 is less than or equal to x squared less than or equal to 90, which has the least value? 50 less than or equal to x squared less than or equal to 90. Okay, take the square root of everything. So square root of 50, square root of x squared, and the square root of 90. So this is approximately 7.1. This just becomes x, and this is approximately 9.4. So since x is an integer, x looks to me like it's either 8 or 9. But here's the thing. It could also be negative 8 or negative 9. Correct? Because if you put negative 8 into there, or negative 9, and square it, it becomes a positive number, and therefore would satisfy that inequality. So those are the 4 values of x. And if you got to just these 2, you should know that there's 2 more just because they told you that. So it's very helpful that they said that there's 4 values. So that's why, you shouldn't have missed the other 2. And then of those 4, which has the least value? Well, the least value of those 4 is obviously the negative 9. When the average of 2002 positive numbers is divided by their sum, the result is x. What is the value of x? Okay, so we have 2002 positive numbers, so let's label them x1 to x 2002. And to get the average, we divide by 2002. And then they're saying that's the average, so that's the average of these. And then they're saying this is divided by their sum, so x1 plus x2 plus dot 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 plus x2002. And they're saying that result is x. Okay, I'm pretty sure that's the algebra. So this whole thing is the same as that. So we'll just call it sum instead of me writing it all up all over again. So really what that is sum over 2002 over sum is equal to x. So if I invert and multiply, it becomes sum over 2002 times 1 over sum is x. And then that basically, the sums cancel, so it just becomes 1 over 2002 is x. And I believe that's it. In quadrilateral ABCD, AC is perpendicular to BC and AD is perpendicular to CD as shown. If AB is 11, what is the sum of the squares of the lengths of the sides of the quadrilateral? Okay. Well, first thing, let's label this. Call this X, Y, Z. I guess I have to label that too. I'll label that W, I guess. It doesn't really matter. So we're going to use a whole bunch of Pythagorean theorems. But before I start, I want to actually decide what is it that they're asking. The sum of the squares of the lengths of the sides of the quadrilateral. So they want 11 squared plus x squared plus y squared plus z squared. This is what they want. So I obviously have to get a numerical value for that. Okay, so this is going to be a whole bunch of Pythagorean theorems. So from the triangle ABC, that's basically w squared plus x squared is equal to 11 squared. And then from triangle, where do you want to go next here? I guess triangle ACD, that would be w squared is equal to y squared plus z squared. Okay, let me look at that one there. Let's see here. W squared, let me first see if I did that correctly. I think I did. Okay, I think I can just substitute this into here. So instead of w squared, I just write y squared plus z squared. And then the remainder would be, the rest of it would be the same, is 11 squared. So I've got a lot of that there, and then I just have to add that 11 squared to both sides. And there you go, I got it. So exactly what this is there, and And the numerical value is 11 squared plus 11 squared, which is 121 plus 121. And that, of course, is 242. After painting a cube of edge length 16, I cut it into 64 smaller congruent cubes. Then I took the smaller cubes on which no paint appeared and cut them into cubes of edge length 1. How many such 1 unit cubes resulted? Let's draw a cube and let's try to figure out what is happening. So here's the cube, and here's the original cube, right? So let's label it. It's 60. Edge length is 16. Okay, edge length is 16. I got it. Okay, so then they're saying it's cut into 64 smaller cubes. So if the original cube was 16 times 16 times 16, and that is 4096, that total volume. Now you're taking that total volume and dividing it by 64, right? Because 64 smaller cubes. So then that means each of those smaller cubes has a volume of 64. So since the edge length cubed is 64 for each of those smaller ones, that means the edge length would be 4. I got it. So I've got to divide these into 4 by 4 cubes. So let's see if I can do that without making this too messy. Okay, that's pretty decent, I think. Just to get an idea. Okay, not perfectly drawn to scale, but that's basically the division. Then what they're saying is you have painted this cube, like all the sides that you see. And they're saying that when you then remove each of these 64 cubes, smaller ones, there's some cubes that will not have any paint on them. And they're asking how many of those cubes exist. Well, actually, that's not true. That they're going to cut them further. But first, let's just concentrate on how many of those cubes there are, and then we'll cut them into these edge length 1. Okay. Well, I stared at this, and I think some of it is obvious. Obviously, this whole slab is painted, so that's 16 cubes. And then the back slab would be very similar, right? That's all painted, so that's another 16. And then let's concentrate on these guys here. That's going to be 1, 2, 3, 4, 5, 6, 7, 8. So 8 of those. And then there's going to be another 8 on the other side that are pretty much exactly the same. And then the top ones, 1, 2, 3, 4 on the top, and there'd be 4 on the bottom. So I'm pretty sure that's the full total of the cubes that have some paint on them. So 16 plus 8 plus 4 plus 16 plus 8 plus 4. So that's the cubes that have paint on them. And that is 56. Now the total number of cubes is 64. So the cubes with no paint, so cubes with no paint would therefore be 64 minus 56, which is 8. Okay, so now that's not the answer to the question. That's just part of it. Now what we have to do is we have to take those 8 cubes that have no paint and cut them. So we have 8 cubes, and these were edge length 4, right? So each of these 8 cubes is an edge length of 4. So we have to cut them into edge length of 1. Okay, so edge length of 1 would be like that. Yeah, very similar actually to what we did before. Okay, not the prettiest, but oh geez. Well, you guys understand. And the bottom line is, when you do that, how many did you make? And you would make, this would be 64 1 by 1 by 1 cubes. Yeah, it was pretty much the same story as there. So then you have 8 cubes. Each of them is cut up so that it becomes 64 small cubes. So the total, grand total, running out of space here, will be those 8 times those 64, and that, I believe, is 512. So a little bit of thinking involved, but isn't too bad. The cubes of 4 unequal positive integers in each of the equations are written as pairs with equal sums. In each equation, the only positive integer that's a factor of all 4 integers is 1. There's a fifth such equation, in which the sum of the cubes in each pair is less than 64,000. What is the fifth equation? All right, so I think we can figure out that fifth equation by just looking at these four. So for example, this one, 9 cubed plus 15 cubed is equal to 2 cubed plus 16 cubed. We'll call that equation 1. And I'm going to use the other one, 9 cubed plus 34 cubed is equal to 16 cubed plus 33 cubed. And that's equation 2. Okay? So then you have to use these. And I think the best thing to do is just do 2 minus 1. That way the 9s and the 16s will disappear. And what you'll be left with is 34 cubed minus 15 cubed is equal to, on the other side, it will be 33 cubed minus 2 cubed. Now, this is a relationship, but it's not a sum. See, they want a sum. So that's no problem. We can just rearrange it to make it a sum. Bring the 2 over and bring the 15 over. And there you go. That is a sum. But here's the thing. It also has to satisfy this, that the sum of the cubes in each pair is less than. So we got to calculate what is this and what is this. And when you do, you find out that it's 39312. And that is indeed less than 64,000. So it satisfies the condition of the question. So what they're looking for is this equation, which represents the fifth such equation.